Hello and welcome. In this video, we'll discuss how to multiply powers. For instance, what would you get if you multiplied 5 to the third power by 5 to the fourth power? Let's find out. Just a brief reminder of what powers really do is they represent groups of things. For instance, this diagram can be represented by the expression 5 to the fourth power. One skill that will be key in this discussion is being able to take a long form expression and write it in short form. 1, 2, 3, 4, 5 factors of 2 is represented by 2 to the fifth power. And going the other direction, if we take a short form expression like 15 to the third power, we should be able to write that out in long form with no difficulties. Okay, with that being said, let's study the example 5 to the third times 5 to the fourth. Well, 5 to the third is just 5 groups of 5 groups of 5. And 5 to the fourth is 5 groups of 5 groups of 5 groups of 5. In other words, it can be represented by this. Notice that the first expression represents 5 to the third power, and the second expression represents 5 to the fourth power, and we're just multiplying those two things together. In fact, if you count how many factors of 5 there are, you'll see that there are 7 factors of 5. So the short form expression for this guy is right here. What happens when you multiply 5 to the third power by 5 to the fourth power? You get 5 to the seventh power. Voila. To give you a sense of confidence that that really is true, you might take a calculator and check that 5 to the third power is 125 and 5 to the fourth power is 625, and use your calculator to multiply those two answers together and check that you get 5 to the seventh power, which is 78,125. Okay, let's talk about generalizations of the problem that we just looked at. The first thing to notice is that there's really nothing special about 5 in this discussion. In fact, we could have the same conversation about 9. 3 factors of 9 multiplied by 4 factors of 9 should give 7 factors of 9. That makes a lot of sense. In fact, nothing special about 5 or 9. We could use any number, call it x, and we'd see that 3 factors of x multiplied by 4 factors of x gives 7 factors of x. So for any number x, these two expressions should be equivalent. The second thing to notice is that there's really nothing special about 3, 4, and 7. In fact, I could multiply 2 factors of x by 6 factors of x, and altogether I'd have 8 factors of x. Finally, nothing special about 3, 4, 7, 2, 6, or 8. I could start with any values, call them a or b, and if I had a factors of x multiplied by b factors of x, altogether I'd have a plus b factors of x. Notice the pattern there, 3 plus 4 equals 7, and 2 plus 6 equals to 8. And if you link it back to the example where we actually wrote things out, you can see that that actually makes a lot of sense. In fact, for practice, you could try writing out this example and this one. Give it a go. Okay, finally, let's look at an example of how we can put that principle to work. So let's multiply 2 times 3 to the fourth power times 5 to the third power by 7 times 3 to the sixth power times 5 to the fifth power. The first thing to notice is that 2 groups of 7 makes 14. Second, 4 factors of 3 multiplied by 6 factors of 3 ought to produce 10 factors of 3. And lastly, 3 factors of 5 multiplied by 5 factors of 5 is altogether 8 factors of 5. So there is a more compact and simplified version of the original expression. These should have exactly the same value. And isn't that helpful to be able to write that in a simpler form? Hope that helps you understand how to multiply powers. By the way, you can do exactly the same thing with variables. If I wrote x to the fourth times y to the third, you could do the same stuff. Thanks for watching.